To meet you all. So firstly, thank you very much for joining. I think numbers have definitely thinned out since this morning, and I'm honoured that you've joined me as opposed to drinking cider in Hyde Park. So thank you very much. So I'm Kayne. I'm hopefully going to try and tell you about some of my experience with SAS in terms of the AI ecosystem or things that I've done with SAS and also in my previous walks of life. I'm also going to start with a little introduction about where AI has come from, a little bit of history about AI, so hopefully you find it useful. So over the course of the next, 35 minutes, I'll try and save 5-10 minutes for questions at the end. So over the course of the next 35-40 minutes, I want to try and get across 3 things. So firstly, we're in a great place, we're in a great time. AI is really taking off. And we're going to be the ones that contribute to its overall effectiveness. And I think we should be honoured that we're in that place. I think it really is a great time. And we can be doing some great stuff in the next few years. Secondly, we need to be talking more about AI. Certainly for what I've seen is a lot of hype. But I'm here to try and dispel the myths, really. What AI is, and talk about the use cases that people think of when they think about AI, and ultimately try to make sure that we're defining the AI objective, the objective of our AI agents, to be exactly what we want it to be. And lastly, the fact that SAS has AI embedded throughout its technology. I'm not here to make a sales pitch today, but obviously I do want to talk a little bit about SAS's AI capability, because we tend to find that customers pigeonhole us into a certain place and maybe don't think of us when they think about AI. So hopefully I'll change that mindset in the next bit of time. So I'm firstly going to try and pick apart the I when we talk about AI. I think there's really a sliding scale when we think about the intelligence. We're sometimes fooled into thinking that something's really intelligent, but actually it's just because it's got a nice, pretty front end, so the artificial part of it. If you think about chatbots, for example, yes, they're great, but often what they're doing is just looking up a massive database of questions and answers. Sometimes it's not actually that intelligent. So I'm going to take you along that journey about how AI and the intelligence in AI has changed. So does anybody know what this is? Ooh, silence. Few nods. So this was 20-odd years ago, 21, 22 years ago. IBM built a system, Deep Blue, to take on a reigning chess champion, Garry Kasparov, at the time at a game of chess. They played a 6-game match. And what actually happened was that Garry won the first one, IBM Deep Blue won the second one. There was then 3 draws, and then by the final 6th game, Garry was so tired, so exhausted, that he just basically made a ridiculous move that basically led to IBM winning. And interviews afterwards and beforehand, he had absolutely no idea that any system would be able to have that level of intelligence. I remember I was probably about 6 or 7, actually. I used to play chess with my grandma, and she told me about this, and I was like, that's absolutely nuts. How can they do that? So I started scribing about things like, what do you need to do in each situation? And I started realizing, actually, this is quite impressive. But if you start to think about what they actually did, really, they're building up I suppose it's a best next action system. So they evaluated what would be the probability of winning the match if I made every single possible combination of move in every situation. Now, if you think about an 8x8 grid with 32-odd pieces, there's actually only so many pieces, only so many plays that you can make. So in terms of how impressive it is, it's more from a memory, a brute force memory problem as opposed to a statistical problem. So it was great, but I think this was the start of the AI journey. So moving forward into a bit more intelligence, talk about use of unstructured data.
Please, God.
What will you say if I told you there is an app on the market?
We're past that part. Just demo.
No?
Okay.
Sorry, guys. I've got it as loud as I can go. Classic IT problems, eh?
It's ready.
There we go.
Please, God.
What will you say if I told you There is an app on the market.
We're past that part. Just demo it.
Okay. Let's start with a hot dog.
Yeah, it works!
Huzzah!
Jin Yang, I'm going to buy you the palapa of your life. You'll never feel exposed again.
I'm gonna be rich. Do pizza.
Let's do pizza.
Yeah.
Okay. Pizza.
But not a hot dog?
I'm glad that got a good laugh.
That's it? It only does hot dogs?
No, and a not hot dog.
So I really like this. Anyone seen that before? Yeah. Ultimately, it's a classification algorithm, right? So a binary target and doing it on unstructured data. So it's intelligent, but we can go even further. I heard a similar anecdote the other day where a colleague told me about how Google are really struggling to classify the difference between a Labradoodle and fried chicken. Has anyone heard that one? Because if you look at pictures of them, they're very similar, and the algorithms really struggle to distinguish the difference. So moving on to something I think is even more impressive. Does anyone know what this is? Yeah, fantastic. So this was the game of Go, and this time this was Google. So Google, DeepMind, took on the reigning Go champion at the time, Lee Sedol of South Korea. I don't know much about Go, I'll confess that, but what I do know is that it's a far more complex game with many more pieces, many more moves that you can make, and a much bigger grid, which means from a computational point of view, it's really hard to evaluate it in the way that IBM did it against chess. So what the Google guys actually did is they developed a series of algorithms and used reinforcement learning. So what they actually did is they started off with a single layer neural network, and they trained it on 70,000 human versus human games. So been able to trawl all of that data historically and build up that first layer. What they then did is they built in subsequent layers of where they simulated computer versus computer games. So what they were able to do is start training very quickly, almost into the future, what would happen if you were able to simulate a lot more games. They started off very simple, and they ended up with lots of layers of these neural networks. And it means that you can start thinking about moves that really maybe humans wouldn't have thought about. So partway into one game, move 37 is the black one on the kind of the middle right-hand side there. Go prescribed that as the next move. Now, again, I don't know much about Go, but from what I understand is it's very unusual to play anywhere other than the third or fourth line in from the edge. Now, they went and played on the fifth line, and this guy, Lee Sedol, was like, what? What's going on? Completely beyond human comprehension as to what you should do as a strategy to win that game. So he actually stormed off, spent 10 minutes out the back thinking about, well, what am I going to do? This is ridiculous. Actually, within a few moves later, Go won. So it goes to show that sometimes humans are limited by the training, just generally how we learn certain games through our ancestors. Actually, it's still quite primitive, and actually Go was able to simulate so many games so quickly that it gained so much more intelligence. So I think this was truly impressive. So in terms of the approaches that they use, these reinforcement algorithms, what really are they? So this is fundamentally what we call deep learning, and SAS do deep learning. This is a little bit of the sales pitch. So firstly, deep forward networks. So this is actually what Google used. This is just a simple neural network, but with multiple layers. Very much more efficient. So I learned the other day that if you want to multiply n numbers together, so say you want to multiply 5 numbers together, in a single layer neural network, you need 2 to the n nodes. So that's 32 nodes. But if you have a multiple layer structure, you only need 4 times n nodes, so you'd need 20 nodes. And obviously that difference will proliferate as you're trying to multiply a larger number of n, which means that obviously You don't arrive at a better solution, but in terms of compute power, you need is far more efficient. You need less memory or disk. So I thought that was quite a nice use case to bring it to life a bit. We also have convolutional neural networks. So these are particularly powerful when you're exploring unstructured data, particularly images and videos. So I've got an example in a minute where I'll show you this. Recurrent networks. So this is the algorithms that you'll use where you have a time element in your data. So you might want to do some forecasting. You might have, for example, call center logs from a customer level where you've had multiple calls. Also videos, you can use these approaches too. And then lastly, autoencoders. So these are the unsupervised babies of the deep learning world. These are the kind of the principal component analysis. So it enables you to do the feature extraction and also being able to do your variable transformations as well. So these are very powerful that you might subsequently feed into a later algorithm, or you might just do some sort of clustering with it on its own. So this is, if it plays, there's no sound to this one. So this is an instance of where SAS has used a technology called SAS Event Stream Processing to do real-time running of deep learning on a video of this gentleman that's in R&D in North Carolina. And as you can see, it's trying to prescribe to what extent he's angry or happy. And you might think, oh, well, what use is this? Well, we're actually speaking to a large broadcasting corporation, can't name them, about using this type of technology to understand people's sentiment to new audience material. So if they want to broadcast a new program online, what are the points in it that's going to trigger emotion, whether they find it funny or sad? And then you can start thinking about actually how AI can start stitching together the perfect piece of movie material that you'll ever watch. Again, beyond human comprehension of what someone might be able to direct. And it seems a little bit blue sky, doesn't it? But actually, we're talking to these guys about this at the minute, and yeah, really exciting. So how do SAS define AI? So simply, it's the science of training systems to emulate human tasks through learning and automation. So there's a few things here. So firstly, it is a science. It is not an art. It is not potluck. It is not magic. You do actually have to do some work. But for us, it's all about just systematically training models or training frameworks using the most accurate data that you have available to drive better business decisions. Secondly, it's about emulating human tasks. Note it doesn't say job replacement. I'm not going to talk too much about job replacement today because I'll be here for the rest of the time. But it is about empowering humans through automation. So if you can take some of that process away and automate it where possible, it means that they can start adding that human intelligence, right? So they, for example, people in call centers. I used to work for British Airways, and we used to surface a lot of data to our call center agents, and they just didn't know what to do with it. So then we started almost informing a dialogue as exactly what they need to be saying to particular customers based on their demographics, and it starts leading to more informed conversations, again, taking that data work away from them because they don't want to be doing that. And again, last one's just learning. Again, there's a sliding scale in terms of learning. I think, I don't know, maybe for the last 10 years, we've been building predictive models by bringing our data down from our data warehouse, whether that's Teradata, Oracle, etc., down into SAS. We'll train a model once, and then we'll deploy it back into database. What that means is that that model is going to degrade over time as data changes, as customer preferences change, as behavior changes. So what you would really want to do is start making sure that those decisions are being recalibrated as your data is changing. So that learning almost takes us towards that reinforcement learning, so where your algorithm structure is actually changing dynamically as your data changes. So if you think about a simple logistic regression, for example, you've got a few beta estimates. What's actually happening is those beta estimates are adjusting in real time as your data is changing to make sure that you've got the most predictive model working. So some really powerful stuff there. So for us at SAS, AI is just an evolution. 10 years ago, people were talking about data mining. That was the buzzword. 5 years ago, it was big data. A couple of years ago, it was machine learning. And now it seems to be AI. Obviously, the hype cycle kind of has been following that, but we see it fundamentally as the same thing. You're training, like I said earlier, you're training systems to determine better business decisions through accurate data and through the leading edge algorithms. So this is nothing new for us. We were doing neural networks 42 years ago when SAS started for forecasting. Our CEO still advocates that he's still learning. He wrote the software. He's still yet our CEO. He's 70 odd. He's quite funny when he's on stage because he's quite slow. But he said the other day, and I saw a webcast, and someone asked him, Jim, what are you learning? And he was like, I'm always learning. At the minute, I'm trying to learn how a neural network actually works. And they're like, well, how's it going? He's like, I still don't have the foggiest, which is fair enough because they're quite complex. But again, it just shows that we're still thinking about our product. We're still trying to put as much innovation into our product toolkit as possible. And we're the biggest, because we're privately owned, we're able to pump a lot of our profits back into R&D to make sure that it really is up with the times. Last year, we pumped, I thought, 26% of our profits back into R&D, which is far more than any other software company. So it's an evolution, but an evolution in terms of three things. Firstly, in terms of architecture. I'll talk about that a little bit. Secondly, in terms of UI. And thirdly, in terms of the analytics that's actually under the hood. So let me build that. Lots of builds. Whoops, too quick. So 40 odd years ago, people had SAS desktop licenses, base SAS, just a programming console that they can submit code to do data extraction, data manipulation, a little bit of modeling. That's fine, but you're limited by the power of your PC. So what people started progressing towards was patterns where they were exploiting server architecture, whether that be virtual servers or physical. Far bigger memory, far bigger disk, and it means that they can solve bigger problems. But even then, as data grows, it's still going to be problematic on some servers. So we progressed about 5-10 years ago to what we call SAS Grid, which is basically lots of servers stitched together. It's a cheap Hadoop, if you will. It's just distributing your workload amongst your grid and making sure that those jobs run as efficiently as possible. Then moving along to the right, there was a pattern where mass data movement was frowned upon. So it was all about pushing your analytics to where the data resides. So hence came about in database technologies. So this is where, again, I was talking about that pattern where you might have Teradata or Hadoop or Oracle. You bring it down, you build a SAS model, so a machine learning model, say a simple logistic regression. But how do you then productionize that on an ongoing basis? You don't, for example, if you want to score on a nightly basis, you don't want to have to re-download all of that data into SAS, run that SAS process, and send the data back to your data warehouse. For us, it's all about making sure that you run that analytic where the data resides. So what we do is we translate that SAS model into whatever technology we need to. So we have SAS embedded processes that run natively within other data warehouses. And it means that you can actually just set up jobs that mean that you can always cut ties with SAS, and you can just run that model on an ongoing basis, exploiting the kind of the power of your Teradata, Oracle, SAP, whichever warehouse it is. So that was the pattern that people were exploring a few years ago and still are doing, especially with Hadoop. But now it seems to be, especially with things like Hadoop, it's all about in-memory distributed analytics. So our latest and greatest platform, SAS Via, which was announced 2 years ago, sits on a massively scalable environment. So we're talking about stitching a lot of in-memory processing together so that you can run processes much quicker. So we've got, for example, retailers that are doing demand forecasting for their supply chain, and they're running like hundreds and thousands of SKU-level forecasts, so forecasts for their time series, in about 40 seconds. It's absolutely nuts, and you definitely couldn't do that with older architectures. Secondly, in terms of UI, so who likes to code still? Most people? Yeah, I used to be one of those. I used to love getting my hands dirty with R, Python, Spark, SAS, all of it. But what I started to realize is that there's only so many projects that you can deliver in that kind of scalable way. So we haven't started. We've got visual interfaces that enable you to do analytics a lot quicker. Some people shy away from these, but I've started to realize the advantages of them. So on our top left there, that's almost our BI platform, if you will. So we call it Visual Analytics and Visual Statistics. This is where you can do ad hoc data discovery. It's where you can build dashboards in a very compelling way and surface that insight across an organization. But for us, it's about more than that, because anyone can do that. It's about using that as a stopgap, as a way to do ad hoc data discovery that might then lead into data modeling. So you can use this interface to do decision trees, for example, or gradient boosting, or neural networks, whatever you want to do. But what you then want to do is port over that IP that you've developed into a bit more of a robust process. And that's where we port it over into something what we call pipelines. Now, pipelines are just a unique combination of specific analytics stitched together to enable you to build some analytical process. So what we have there is VDMML, very good name for visual data mining and machine learning, is a pipeline to enable you to compare the effectiveness of various supervised learning approaches like gradient boosting, neural networks, because ultimately you don't want to just explore one decision tree up here. You want to explore the effectiveness of lots of different models by changing lots of different parameters. But we also have those pipelines, the same for forecasting, time series forecasting, and also for text analytics as well. So we're finding that a lot of customers are finding a lot of advantages of exploring that kind of technology, bringing SAS coding, bringing R code and Python code in, and using SAS as a platform to govern and automate their modeling. So really powerful. But fundamentally, all of this sits on top of SAS code. So if you want to do SAS code, you still can. So they sit on top of what we call procedures. So if you wanted to run a logistic regression, there's a particular procedure that you call for that. So SAS is its own programming language. But the reason why it's taken a couple of years to really get VIA into its own is because they completely rewrote the language from the ground up to facilitate one thing, and that is openness. So what they've done is they've set these procs on top of what we call actions and action sets. And these are little snippets of code functions that can be called from outside of SAS. So if you have SAS licensed, you can call SAS IP from Jupyter Notebook. There's a Python package called SWAT, S-W-A-T. Feel free to explore it. And it means that you can start embedding SAS IP into your Python workflows. We've got the same for RStudio, and we've got open APIs for things like Java as well. So it means that we're trying to open up SAS so that it can be accessible by not only all people across levels of the organization, but different skill sets as well. So data scientists aren't coming through from university with just SAS anymore. It might be a little bit of SAS, a little bit of Python, a little bit of R. We want to facilitate that collaboration of those people. So we're offering them a platform to bring that stuff in, compare their Python model, their scikit-learn model against an R XGBoost model, against a SAS gradient boosting model, and try and find the most predictive approach. And in terms of analytics, the third thing, for us, we talk about something called the analytics lifecycle. So we are not a point solution that just do BI. We are not a point solution that just does modeling. We are a complete solution that does everything from your data ingestion. So we have SAS access engines into lots of different data warehouses, but we also have data quality, data cleansing, data integrity tools there. But you might also start doing some just data visualization as well. Then you go into discovery. This is where you start doing statistical analysis, a little bit of modeling, time series, text analytics, deep learning, all that fun stuff. But then it's about turning that insight into a productionized process, and that's where the deployment angle comes in. And we think that these map quite nicely to the different techniques that you think of when you think about AI. So you might not think these are AI techniques in their own right, but I see these as the building blocks for successful AI. Visualization, you can't build a successful predictive model without inspecting your ROC charts, for example. Data management, I'm sure you've heard rubbish in, rubbish out, right? So you need to make sure that the data that you're feeding into your models is as accurate as you can. When we think about the analytics we do down here, we'll then want to deploy that on an ongoing basis. So I talked about the in-database technologies. That for us is deployment. But sometimes it's not about a business just executing action off one model. So you might have a churn model, but you might also have upsell models, cross-sell models, recommender systems. You've got so much predictive insight that you don't know what to surface. And that's where you need this kind of decision support. It's an arbitration engine where a business can govern what they want to push to what customer to drive a particular KPI, whether that's maximizing profit, revenue, sales, minimizing cost, whatever that objective function is. So that's decision support. But those aren't the sexy ones. Those aren't the ones that you read about in the media when you talk about, when you hear about AI. That's usually these four. So starting from the right-hand side, machine learning. Machine learning, to me, is quite simply variants of three things. Variants of regression, so logistic, linear, ridge regressions, Shapley value regression, partial least squares, list goes on, right? Tree networks, so decision trees, gradient boosting, random forests, and also network structures, so neural networks, Bayesian networks, deep learning networks. So really, these are just evolutions of the primitive statistics that we were exploring years and years and years ago. Just been evolved a little bit. When we move into computer vision, what we're doing is using those same algorithms, that same IP, but just exploiting it on top of unstructured data. So computer vision for us is about running processes, analytical processes, on image data and video data. Then moving across, a different unstructured data source, natural language processing, or natural language understanding, as we're getting to. So this is about being able to use machine learning approaches to be able to identify clusters, for example, in your text documents. But it's also about building in linguistic rules as well, so that you can understand things like sentiment associated to maybe customer complaints. So this is really powerful. When I worked at BA, I brought in SAS natural language processing, and they're using it a lot to, for example, classify complaints, call center reports. They're using it for engineering as well, so deriving a lot of value from that. And lastly, forecasting and optimization. And also, since I'm an OR nerd, simulation goes in there as well. So forecasting, we've got customers using forecasting capability for, like I said earlier, demand-driven forecasting to understand who's going to buy what when. And optimization really is the holy grail that organizations are striving for. If you think about the analytic journey of a typical organization, we talk about descriptive to diagnostic to predictive to prescriptive. That prescriptive, that's the holy grail, that's the optimization. You're saying not only what has happened and what will happen, but what should I do to make sure that I'm driving my optimal KPIs? And that's really where organizations are bidding to be. So to talk about a few use cases in terms of where I've seen AI used successfully, both within SAS and previous life. So banking, fraud detection. So fraud is increasingly an area that is just losing lots of businesses, lots of money. So if you're able to dynamically adjust your algorithms to be able to detect fraud in real time, that's hugely advantageous. So what we find is that customers years ago were detecting fraud, building models to detect that type of fraud going forward. But by that time, customers' behavior had changed. They'd learned a new loophole. So it's all about being able to evolve very quickly. Credit analysis. So not just for banking, but if you think about retailers that offer credit as well, it's all about being able to make a decision on the fly. Capital One, for example, can prescribe whether you're going to be given credit there and then. And that's using SAS in the background. That's using machine learning in real time based on the data that you've been given there and then. And automated financial advisors, these really are chatbots, right? So it's about giving the best advice possible. In terms of government, smart cities, IoT, I'm sure you guys have heard about that. It's all about leveraging all of this data that's across a smart city, joining it together. A nice use case here is about being able to understand across a city energy consumption. So if you're able to understand how much energy is being used when. For example, people talk about a surge just after EastEnders because everyone's gone to make a cup of tea. If we're able to detect that, then maybe they can procure their energy from energy suppliers in a more cost-effective way, so better kind of demand forecasting. Sensor fusion is, again, about, if you think about using other IoT devices. And facial recognition. So have many people passed through the Heathrow passport gates? Yeah, that's all facial recognition, right? So that's trying to marry up what your image on your passport looks like to what that picture that they've taken of you there and then looks like. So what they're doing is basically looking at the pixels in both images and saying what is the degree of overlap between the images. If it's over a particular threshold, fantastic, you go through. If not, you're usually pushed back out again. Health and life sciences, so predictive diagnostics. So health companies are definitely looking towards this. Who's got a Fitbit or some sort of smart device on their wrist? Not as many as I thought. Come on, guys, we're data guys. We should be hungry for that sort of stuff. So this is all about being able to digest that data. I've actually got a colleague that downloads his Fitbit data, and he's got visual analytics, the dashboard that I showed you earlier, visual analytic dashboards of all of his data. It's a bit nerdy, but it's quite funny. Biomedical imaging. So I've heard some use cases about, I think the one that resonates the most with me is the University of Catalonia are doing screening of X-rays, and they're able to prescribe more correct decisions about diagnosis than humans can, which is mind-blowing, really. But it kind of shows where the future is going. Health monitor, again, is being able to use things like Fitbit data. Manufacturing and energy, so supply chain optimization. So this is about not only understanding your demand at any given point in time, but being able to action that in the most appropriate way. So when an organization does SKU level forecasts, so like the retailer that I was talking about earlier, what they need to decide is how much of what do I order when, given constraints around the business that I have. So they're going to have different transportation times and costs. They might be able to expedite produce from one store to another if they want to do that. They'll usually have multiple delivery channels, and they'll usually want to meet a certain SLA in terms of the demand that they meet. So that's all a massive optimization problem. We offer that for many customers like Nestle, Levi's are a big supply chain optimization shop as well. Automated defect detection. So this is where, again, it goes back to IoT. If you think about manufacturers and all the plants that they have, well, they'll have lots of processes joined up to maybe make a car, for example. Each of those processes will now have sensors associated with them to understand different things. And it's all about bringing all of that data together and understanding what drives predictive quality. So are you able to detect faults in that process based on environmental factors? Or are you able to isolate why a particular product comes out of that faulty based on all the data about the raw materials that you've fed in, but also data about the sensors that you've captured along that journey as well? So again, a lot of really good stuff there. And finally, energy forecasting. So I talked about this a little bit earlier. And lastly, comms, conversational chatbots. I'm sure people have engaged with one of those over time. They're definitely coming about all the time. Contextual marketing. So this is, for me, recommender systems. But it used to be, what did someone recently buy? Therefore, what are they likely to buy in the future? Now it's evolved a little bit more than that. People are using in-session behavioral data. So Shop Direct, for example, we're looking at integrating their in-session data as well as their transactional data to empower the best recommender system possible. So again, it's using the most accurate data that you have available. And network analytics. So this is quite a new field, so graph analytics. That's really come into its own. We did a piece of work actually with this broadcasting corporation where we demonstrated the value of teams working together better. So if you can isolate different people and the attributes that are associated to them, what do you need to make the optimum team? And we're working with another energy company to be able to provide that kind of management consultancy. but that's using analytics. So that's all well and good. Lots of really good stuff in there. So hopefully AI hasn't been seen as, well, one of my colleagues would say, AI are not like cookie cutters. You can't just stamp what you want. You have to think through exactly what your objectives of your AI agents are. What are you trying to do? What's your objective? What are the constraints? And this was first discussed a few years ago, believe it or not, only 3 years ago, 2015. Does anyone know what this is? Has anyone seen this? No? So this is the very first AI safety conference that took place in Puerto Rico in 2015. Leading visionaries in the AI space like Stuart Russell, Max Tegmark, Bill Gates, all these people came together to start thinking about the foundations of what people need to talk about and think about when they're embedding AI agents. In his latest book, Life 3.0, has anyone read it? Max Tegmark book. It's really good. They start to explore kind of the ethics of AI. I think it's a really interesting read. I'd definitely promote it. And they start to hypothesize a fictional situation where a team of researchers develop an AI agent, which they call Prometheus, and they deploy it on the internet. And he quite nicely articulates how actually if you don't control the problem appropriately from the offset, what actually happens is that it starts downloading the whole of the internet, it starts forecasting stock markets, it basically takes over the global economy, and you start arriving at quite bad conclusions, i.e. a jobless society. So we need to start thinking about what do we need to be in place in terms of rules, governance, and laws to be able to govern these AI agents. So I just want to talk about a couple of differentiators in this AI space for SAS. So firstly, I talked about AI not being cookie cutters. You do have to put a little bit of work in, and that's why SAS is uniquely positioned to offer a platform that really enables you to make those solutions yourself. Very flexible programming console, but also out-of-the-box visual capability as well. I was talking about different levels of the organization. We're well established across the enterprise at all levels. So CXOs are digesting our dashboards, middle management are doing ad hoc data discovery, and we've got data scientists using our toolkit to do things like deep learning as well. Governance. Governance is very important, right? So there's lots of people, lots of auditors coming in and trying to understand why did this customer get this particular marketing treatment, for example. It's really hard to understand that lineage in open source, which is why we often find that businesses will use SAS as a means to contribute their open source efforts like R and Python, alongside the SAS stuff that offers that governance and that automation. In terms of deployment, a couple of people asked me about this today. We're not limited to one kind of pattern or another. Really flexible. We can offer results if you just want to throw us the business problem. We can host it in our own data centers. We can host it in your data centers, public cloud, private cloud. Yeah, anything's possible. Simplified end-to-end integration. If you want to see this in action, pop by our booth later, because we've been given a couple of demos about how you can go from that data discovery to modeling to deployment at the click of probably about 10 or 11 buttons, which is really impressive. Analytical streaming engines. Hopefully you saw the event stream processing video where we're able to do that. Streaming and analytics in real time on that video. We're able to do that with a lot of customers. And the fact that we're 42 years old, we've got a bit of longevity, we're internationally supporting everyone, so we can just really support. Just coming back to the 3 takeaways. So like I said, AI really is an evolution for us. We've been doing it for 42 years. It's nothing new for us, but we're in a great place to contribute to these efforts. Thanks to things like Moore's Law, compute power is massively growing. The analytical approaches that are in our technology is massively growing. I'm also finding that stakeholders, the mindset of business people are completely changing. We're finding that actually people are coming to me. In my previous job, I had a customer come up to me and said, Kayne, I want some AI. I was like, fantastic, what do you mean by that? As we unpicked it, he basically wanted an if-then-else piece of logic to run in real time. Again, not that intelligent, but it was going to drive huge amounts of benefit. Secondly, we need to be having discussion about the objectives of our AI agents. We need to be careful about what we're deploying where. There's not too many logical arguments to make from deploying an AI agent to try and do better customer personalization online to doing something completely more radical. And the third one, the fact that we have our AI capability embedded throughout SAS. Really, analytics runs in the veins of SAS technology and SAS people. So I would really advocate you to come and talk to us at our booth if you've got any questions, because I think we've only got a few minutes left. Thank you very much.
There is time for a question or two?
Yeah, fantastic. Any questions?
No.
Stump silence, or
Please
just want to go to the park?
Well, OK, you don't have to. You can go out. You probably want some fresh air. We have half an hour tea, coffee break, and then we'll continue. Thank you very much. Thank you.
Thank you.